Alright, here's where we're going to work resonance problems. A couple of these problems you will have already seen in the molecular shape, but we want to focus on the resonance part of it. So, again, you do the Lewis structure. We have 5 electrons here, 6 electrons times 2. With the positive 1, we're going to lose 1. So that's 12 plus 5 is 17, minus 1 is 16. So we're going to start with nitrogen as our central atom, and our oxygens is our external. Now, because I like to play with color, we're going to switch colors here. So what we've got here is our original Lewis structure. Now, the question is what do we need? We've only got 16 electrons, and nitrogen is not happy. So the first thing we can do is donate a pair from either one, in which case we end up with oxygen, nitrogen, oxygen, keeping our lone pairs here. We do still have the charge, so we've got to keep that in place. So that's one option. Another option is, well, what happens if we take both pairs from this oxygen? And remember, we're going to differentiate the oxygens by calling them 1 and 2. So at oxygen 1, we'll have the triple bond to nitrogen. Oxygen 2 stays as a single bond. Again, we have the positive. Now, let me see if I can find my green pen, and it doesn't match, but where life is good. We can take the green and see the 2 electrons from each one. So in which case we've now taken, and instead of the triple bond being on oxygen 1, oxygen 2 is going to have the triple bond. Whoops, oxygen. I'll have the lone pairs there, 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 there. Now, again, it's a charged species, so we've got to put the charge on it. And so we'll look at it and we'll say, all right, these are all 3 resonance structures, which we use the resonance structure to determine which one. Now, one other thing that we can do with this is to determine the formal charge. So, formal charge, remember, I'll come up here and write formal charge is equal to the valence electrons minus the non-bonding electrons minus 1/2 the bonding electrons. Okay, so that being the case, oxygen here is going to have 6 minus 4, just 2, minus 1/2 of 4, which is 2. So it's 6 minus 4 minus 2. So formal charge oxygen is 6 minus 4 minus 1/2 of 4, which is 0. So this oxygen is going to be 0. These are identical, so that one's going to be 0. The formal charge of nitrogen is 5 minus 0 minus 1/2 times 8, which means that it gets the plus 1. So here's this structure here. Now, on the blue structure, we have our formal charge of the oxygen triple, which is equal to 6 minus 2 minus, I got 2 bonding, 1/2 times 6, which is 6 times 2 is 4, minus 3 is 1 plus. Formal charge on nitrogen is going to be the same, so it's 5 minus 0 minus 1/2 times 8, which is equal to plus 1. Formal charge on oxygen single is 6 minus 6 minus 1/2 of 2, which is 1 minus. Okay? So for the nitrogen down here, what we're going to have is formal charge of oxygen single, which is going to be the same, minus 1. These all will duplicate so +1, and formal charge of oxygen triple would be 1 plus. So again, your formal charges have to total to give you the overall charge. Now, the best structure here will be the one with the least charges, and that would be the red structure. Okay, let me change colors again. So your best one is the red structure because it has the lowest charges, and there's no negative. We only have a positive, and yes, it's on electronegative species, but what's more electronegative, oxygen or nitrogen? Okay, the blue and green are going to be bad because they have higher charges in general. Okay? So that's one resonance structure. While we're at it, we'll go ahead and finish this one out on the other side of the page. So I'm going to draw a line here to help me out. Carbon has 4. Sulfur has 6 plus 2, which is 12 plus 4 is 16. So we're carbon, sulfur, sulfur. Again, this is very similar to what we had on the other side. So what we're going to do is run the charges. Okay, now again, carbon is not happy, so it can get 1 each from both of them. So sulfur, carbon, sulfur, lone pairs here. And notice it doesn't go in brackets because there's only one. There's no charge overall. So here I can take the lone pairs from the same. So I'll have a sulfur, triple bond, carbon, single. Again, I've got to complete the octets of everything else. And then the last one would be to differentiate the 2 sulfurs. So instead of having the triple bond on the left, I'll have it on the right. Again, once my resonance structures are drawn, and you can do this ongoing or you can do it at the end, make sure you put in the resonance arrows. Now, that means that when we look at this, we're going to look at the formal charges. So here, the formal charge of sulfur is going to be the same, which is 6 minus 4 minus 1/2 times 4, which is 0. Formal charge of carbon is equal to 4 minus 0 minus 1/2 times 8, which is 0. My formal charges have to add up to equal. So here, formal charge of sulfur with a triple bond is 6 minus 2 minus 1/2 times 6, which is 1 plus. Formal charge of carbon is not going to change. 4 minus 0 minus 1/2 times 8, which is 0. And the formal charge of sulfur with the single bond is 6 minus 1/2 times 4, which is equal to 1 minus. Our formal charges add up to equal 0 again. But down here, where they're going to operate the same, formal charge of sulfur single, we've already calculated, will be 1 minus. Formal charge of carbon is going to be 0. Formal charge of sulfur triple bond is going to be equal to 1 plus. So again, they're going to total to give you 0. However, who's the best structure? The best will be the red one. Why? Because it has the lowest formal charges. Okay, that wins. Blue and green here have higher formal charges, so that makes them poorer structures. Now, they all total to equal what you want, so that would be the 3 species that we see for each of these resident structures. We will run 2 more the next